Hello everyone, welcome to this session on building automated flows with AI capabilities for quality control in big environmental projects. My name is Michiel Mateev. I'm Chief Assistant Professor at University of Architecture, Civil Engineering and Geodesy, Sofia, Bulgaria, in Computer-Aided Engineering Department. I hold PhD on cloud computing, and I'm a community enthusiast helping people to learn more about technologies, especially technologies in construction, environmental engineering, and any kind of area related to building industry. My research is mostly focused on different areas around building industry where we can implement automation and where we can use computer systems. In this presentation, we will cover main points related to my research for automated flows for big environmental projects where we are using AI capabilities. We will talk about challenges, methodology, data management, document automation with AI, and of course there will be demonstrated some results. Quality control is a very important part of implementation of big environmental projects, because in such projects we have different models used for analysis plus different documents, and we need to evaluate the quality of these documents. In big environmental projects, we are using mostly last year's data lakes for storage of data from different data sources, and this is one very good technology where we can have centralized repository for different type of data structure. We need to have different flows where these data need to be approved, managed, processed, and shared later with different consumers. With document processing, organizations can build a custom AI model to extract information from documents and use it for different types of analysis. In the current research are analyzed options for smart quality control with artificial intelligence for big environmental projects, and here are used mostly capabilities from Microsoft AI Builder, which is specific component used for different purposes, mostly around democratized artificial intelligence. That means it is possible people who are not very deep in machine learning algorithms and data science can use it for solving of different problems. This AI builder can be used with different technologies, but it stays more popular with low-code, no-code platforms, especially similar to what we have in considered project. In the project are used automated flows using Power Automate with AI Builder. There are three different purposes to use data lakes for scientific projects. First is staging areas or source for data warehouses where we will have data which can be used for different analysis later. The second is related to usage as a platform for experimentation for data scientists. We have this good opportunity to keep the data in the original format and to apply overall different data sources, specific analysis. And third one is related to usage of these data lakes as source for BI and especially self-service BI solutions. Automation flows, and especially document automation with AI functionalities, are critical part for effectiveness using data lake solutions for processing different types of documents. The current research is based on experience with flood hazard and flood risk maps and flood risk management plans for Romania project. This is a huge environmental project for risk from floods in Romania, and in these projects there are implemented automated workflows with AI capabilities, and there is statistics about improvement for different phases when we have usage of automated flows with artificial intelligence elements, and also experience from previous phases where we didn't use such kind of technology. In such projects we have several challenges related to how to optimize workloads, how to meet security requirements, how to optimize cost and minimize the time to market, that means the time for implementation. Of course, everything initially is related also with the proper design of data structure. Current presentation also covers the methodology used for implementation of this project. From the data design part, we have two important concepts related to grouping and organizing of the information into coherent structure, and the second is related to naming folders and files. In the current project there are two cycles till this moment. First cycle is related to data which is already collected in a specific structure during the previous years, and there are not used automated flows. And the second cycle is actually implemented during the last year, where we have including data models for the hazard risk, and this data is organized in the concept this data to be collected and after that consumed from different users, different consumers. Data is structured in three big groups, independent from flood directive and specifics of the different cycles data, and data which is related to the first and the second cycle. Structures of the flood directive independent data is shown in this diagram. We have several levels of containers in hierarchical structure. In data lake is implemented based on Azure Data Lake second generation in Microsoft Azure. Microsoft Azure is Microsoft Public Cloud. Organization of the higher level of data for first and second cycle is demonstrated here, and you see that for the second cycle we have more clear divided structure also by regions. We have several levels of containers in this structure and specific naming conventions for the files. One of the most important parts in this project is related to data management approach. In data management, for the cycle 2 are used 17 different use cases. Based on these cases, we realized different automated flows. Automation is based mostly on low-code, no-code capabilities of Microsoft platforms related to Power Platform, that means Power Automate and Power Apps. From the technical point of view, significant part of these flows are also related to notification between different users, different groups and services is very important to optimize the work in different workloads, and it is critical to have shorter time to market. One very important part of automated workloads is document automation. Document automation can be done in several different ways. We use in this project custom approach for some of workloads, where we are using different options for automation using Power Automate, using Azure services, using Power Apps, and for some flows we use also Document Automation Toolkit, which is end-to-end solution from Microsoft, including Power Automate, AI Builder, Power Apps, and shared database for Power Platform and Microsoft Dynamics, so named Microsoft Dataverse. One of the most important parts of document automation is related to artificial intelligence and how to use AI capabilities for document analysis. Here in this project and research is used Microsoft AI Builder. It is good to share what is AI Builder. So AI Builder is Microsoft Power Platform capability to provide AI models that are designed to optimize business processes. This service enables business to use intelligence to automate processes and have insights from data in Power Apps and Power Automate. AI Builder and Power Automate come with pre-built customized models, which can be used in a variety of applications. I will share a little later what kind of models we can use there. Capabilities are related to several groups. Vision capabilities, where we have text recognition, form processing, object detection, receipt processing used in this research, and also business card reader, which is not part of this project. Language capabilities use language detection, category classification, keyword extraction used in this project, and sentiment detection, which is not so important and for this project, and it was not used here. Prediction capabilities used several different models: binary, multiple, outcome, numerical. We have here usage only of binary model, where we can evaluate if some documents are fine or not regarding to specific analysis. In document automation flows, we have several phases: retrieve documents, extract, validate, export, and monitor our data. Let's now have an overview on the results. Data used in the project is more than 200 terabytes, and it is increasing continuously. Document automation helps to optimize some flows and to decrease time for document analysis and processing from 20-30% up to 3 times. We have more than 18,000 documents where is applied options for vision capabilities of AI Builder, mostly related to object recognition. These functionalities related from one side to analyze specific documents and data for these documents, and also for analyzing of input from some models where based on these outputs, we can have insights if results are close to the expected, because object recognition can help us also to analyze the results. Language capabilities are also used for nearly 100,000 documents from one side to have recognition of specific language, because we have documents in English, documents in Romanian. Also, we have category classification for several categories which we use for documents, and keyword extraction. Prediction capabilities are used to evaluate the quality control for nearly 18,000 documents. As results, we have between 8 to 30% of overall optimization using automated flows with document processing with AI. We have more than 100,000 documents where AI capabilities are used for analysis and document automation. In the next steps, I will try to use this technology in more projects to analyze data for different projects from different project domain, different scope, different data size, and to have some cross-project results. Thank you very much for attending this presentation, and if you have any questions, I'm available to answer your questions.